Hey everyone, welcome back to my channel EduVibe. In today's lesson, we are doing the topic of the Unit C of next topic of grade 11 chemistry, which is the pH and pOH, and we basically doing the major in pH too. So this is like a lot topic we are doing today. The pH and pOH is a very important topic, and then we're doing the measuring. How can we measure the pHs? We do the ranges, we do the averages, that all thing we do in the measuring one. So pH and pOH can be found by the ways we have, and we discuss those ways today. So firstly, what is pH? And then firstly, what is a pOH? So pH is basically the power of hydrogen. The pH is all about the hydrogen and the measure of the hydronium ion. In pH, we already like our main topic is to measure is the measure of the hydronium ion. So all the things we're doing with the hydronium ion when we're talking about the pH and concentration or the acid of a substance, how the acids the substances and all the things in that. Hydronium ion concentration is this, so its pH is 7. If the hydrogen concentration is this, your pH is 2. How can we measure those things? Like with the concentration, we can measure the pH. With pH, we can measure concentration. There are some formulas you have to remember. So we discuss those things and in this lesson. So pH scale, this is the pH scale. We have like 0 to 14. From 0 to 6, we have all the acid things. The 0 is the most acidic. At 7, we have a neutral. The things, some are neutral. From 8 to 14, we have all the basic. And the 14th is the most basic. So we have the alkaline thing. So the broad range of the hydronium ion concentration, we have different concentrations in this. Each change of 1 pH unit corresponds with the change in the hydronium ion concentration of the tenants. So if the pH is changed in every unit, the hydronium ion concentration changes by the tenants. The concentration changes very quickly at very large amount it changes. So that's all about the pH. pH we're talking about basically the hydronium ion. Next we have a pOH. So the pOH is the power of the hydroxide. So in this we have to measure of the hydroxide ion. So again important, the hydroxide ion. This is OH negative. This is this. So in this we have to measure about the hydroxide ion. So it's the same like if we have this concentrations, we have 7, we have this, we have 2. So in this too, we have to measure everything the same, and pH scale is usually the broad range of hydroxide ion concentrations, and each one pH unit corresponds with the change in hydroxide ion concentrations of the tenants. So the everything stays the same in pH. The formulas are also same. Like for pOH, if you have a concentration for the hydroxide ion, you can find the pOH. If you have pOH, you can find the hydroxide ion concentration. The formulas are similar, but just the changes here. pOH we have a hydroxide ion. In pH, we have a hydronium ions. So the first formula is for the pH and the hydronium ion concentration. So if you want to calculate the pH and you have a concentration of hydronium, so you can use this formula. The pH is equal to minus log of hydronium ion concentration. So if they given us the hydronium ion concentration, which is H3O positive aqueous, so you can find the pH by this. So in the calculator, you have the log sign. So you could put the minus, then log button, then put the value of the concentration of hydronium ion. Then whatever the answer is, that's your pH. So in this, the things are very difficult. Like sometimes the signals are made very complex in this. So note, only digits fall with the digit point in the pH value are significant. How it works, I will tell you that. So first let's solve this question, then doing some things. Okay. So we have to calculate the pH of the solution with the hydronium ion concentration of 6.7 to 10 raised to minus 8 moles per liter. Simple thing. So to find the pH, you have to do minus log of 6.7 into 10 raised to power minus 8 moles per liter. So when you find this, you get about 7.173925. So what's your pH? So this of the concentration is 2, but the answer is this. How this is the answer? So in this, basically when you find the pH, when you find the pOH, all things stays the same in pH and pOH. After finding that, you get this long much answer. But you know that in question we have a 2 set this. So this must be a 2 set this. But this has the 3 sectors. No. In the pH and pOH, we have to start counting the sectors after the decimal. So after decimal, we have only 2 sectors, which is 1 and 7. So we can't like count the sectors before the decimal. We have to see them after the decimal. In that case, we have a 2 sectors. How? Which is 1 and 7. So pH and pH also have not any units. This stays 7.17, and 7.17 has how many sectors? 2 sectors. Because after decimal, the sectors should be counted in the pH and pOH. In pH, if we have a strong acid and we have a hydronium ion concentration, we have a hydronium ion concentration, and they also given us the strong acid, and we have to find the strong acid concentration. So the strong acid concentration must be equal to the hydronium ion concentration. That's another main thing in pH, that if you have a strong acid, you have to find the concentration for the strong acid, but you have a hydronium ion concentration, so both should be same. If you have a strong acid concentration and you have to find the hydronium ion concentration, both should be same. So that goes hand in hand. Done. Now you get to this type of question. You don't get this much, like this easy question you got that. You get this type of question. The question says, calculate the pH of a solution made by dissolving the 3.0 grams of HCl gas in 150 ml of water. So in this case, you have to write the equation. So on the knowledge of your modified analysis theory, which we did in the previous lesson, that all things are used in this. So HCl gas, react with water first. This is strong acid, so you get this plus Cl negative aqueous. You have a mass for the HCl. You can find the molar mass of HCl, which is, you can find H, which is 1.01 plus 35.45. You will get 36.46 grams per mole. From the mass and molar mass, you can find the N. Mass upon molar mass, you get 0.08228 moles. You have to find the concentration of HCl. Then, so basically, find the pH. So for pH, you want the hydronium ion concentration. So how can you find this? Basically, if you find the HCl's concentration, the HCl concentration must be equal to the hydronium ion concentration, because the HCl is a strong acid. So you have the volume, which is 150 ml. Done. So 150 ml is like divided by 1000. Yeah. So this V, so you get about 0.08228 moles divided by the 0.150 liters. When you calculate this, you get about 0.5485 moles per liter, which is basically equal to the hydronium ion concentration. So you directly put this thing over there, moles per liter. So when you calculate the pH is 0.2607. So how many this you want? 2 sets. So 0.26. No units. And this is your pH. So the main thing which I mentioned over there in that point, that these strong acids and the hydronium concentration must be equal. And the pH has the 2 sets after. You have to count those series after the decimal. Next, we have a pH and the hydronium ion concentration again. Now, if you have to find the hydronium ion concentration, so you can do the 10 raised to a minus pH, which is this. So for hydronium ion concentration, you have to do 10 raised to power minus pH. Like in this, hydronium concentration, the pH of 5.32. So S3O plus aqueous is equal to 10 raised to power minus 5.32. You have 4.78 sets into 10 raised to power minus sets. So how many sets this you have? You have 2 sets, right? So 4.8 for concentration. You have to count as you have done into 10 raised to minus sets moles per liter. So that's how the concentration, hydronium ion concentration can be found. So it's easy. So you can find by your own. Now we straight to the pOH and the hydroxide ion concentrations. In this, we stays the same, but we have a pOH, but the minus log and OH minus concentration we want. But this stays the same, like same as the hydronium ion. So in this also, the after decimal we have to count the pOH values. But in that case, the hydroxide ions is not equal to as a concentration of base. So as in the strong acids is equal to the hydronium ion concentration, in this we can't take like this. The hydroxide ion is not equal to the value of the base. So the pOH solution you have to find. So in this, what you have to do, pOH is equal to the minus log of 0.27 moles per liter. So what you get for pOH? 0.5686, which is basically the 0.57. No units for pOH2. That's what you can find. And if you have like this type of question, like pOH from a solution of the barium hydroxide, so I have to find this separate thing. Like in this we have a like BaOH2. So BaOH2, which is solid, you have to deassociate this. You will get a Ba2 plus aqueous plus 2OH negative aqueous. So we have to find the concentration for the OH negative to find the pOH. So basically you have a concentration for this 0.050 moles per liter. So you could do find this. So concentration for OH negative is equal to 0.050 moles per liter. So you have to multiply this by 2 divided by 1. You have to multiply by 1. So the concentration of OH negative is basically 0.1 moles per liter. Now we have find the pOH. So minus log of 0.1 moles per liter. You will get pOH of about 1.00. You want to say this as, that's why I put 2 zeros at the after decimal. So that's how the pOH things works with the hydronium ion concentration. Next we have a pOH and hydronium concentration again with to how to find the pOH, how to find the hydroxide ion concentration with pOH. So to use this formula, 10 raised to power minus pOH. So basically, you have to find this aqueous. So 10 raised to power 6.30. What do you get? You get 5.01 to 10 raised to power minus 7 moles per liter. You want two sets, right? So 5.0 into 10 raised to power minus 7 moles per liter. That's the answer for this. So this is again easy thing, same as pH, and pOH stays the same. In pH you have to take care of the hydronium ion concentration. In pOH you have to take care about the hydroxide ion concentration. I repeatedly saying this because this is the important thing you have to know in pH and pOH when we calculating those things. Last thing in this, the relationship between the pH and pOH. When we plus the pH and pOH, you will get a 14.00. You will get the questions related to this too, like the questions where we asking about, like they asking about the calculate the hydronium ion concentration, which is basically you have to find the this thing. But you don't, you have to have a given the pOH of this. So basically you have to firstly find the pH. So pH plus pOH is equal to 14.00. To find the pH, you have to do 14.00 minus 9.50. So what you get as pH? You get 4.5. And to find the hydronium ion concentration, you know this is equal to 10 raised to minus pH. So 10 raised to minus 4.5. You get 3.16 10 raised to power 10 raised to power minus 5 moles per liter. But you want like 2 set this, so 3.2. The extra thing is that they've given you the pOH, but they're asking about the hydronium ion concentration. So you have to use this formula by your own and get the answer. After that, solve for the hydronium ion concentration. The simple thing, you get this something more complex question, which we discuss in a practice question when we're doing that. After that, we have some topic called the Mason pH. In your data sheet and the last page, you have some acid-base indicators. Those acid-base indicators are used to measuring the pH. So how can you read this? I will tell you that. Firstly, what are those? So the acid-base indicators are the substances that change color when acidity of the solution changes. When the acidity of the solution changes, they have some range of that thing, which is called with that the indicators. These are all the indicators: methyl, valine, crystal red, thymol blue, orange 4. They all have, we have a full list of that, and they have some pH ranges. And they have a colors where they change, like from this to this, they change the color. So this how the acidity of solution can be work. So indicators are of different types. You can use a litmus paper. We use a litmus paper for acid base for the simple things. But for the questions to calculate, you have this whole thing which include the Brithamel blue, genetic symbol for any symbol is indicates ion. They have a symbols for this. The symbols you can see from the, like this is the symbols. So you can see this table in your data booklet. How can you deal with those now? Firstly, that there are the two things also where we can find the hints, but you can't, like, you have to just know about this. So pH paper contains a salver different indicators. You can see these have different indicators. They have a whole book like this and show different colors at the different pH values. They show different colors. You can see this in your chemistry laboratory. You have a pH paper, and you also, I think, you're doing the lab for this topic too. That how can we actually use the pH paper so to say that this is the acid, this is the base, or this is a neutral. And we have also a pH meters to provide the precise measure of the pH of a solution. We have this too. You have to just dip this like wire, and this has a pH thing, and you have to put this in solution, and they give you the reading of that. This is very precise than the pH paper. So what type of questions you get? You get this type of questions. So discuss that question one, and we can more practice and when we do practice questions. So in this, the chemical analysis of a separate substance, samples of an unknown solution, phenolphthalein was colorless, brithamol blue was blue, the phenyl red was red, and estimate pH range and average hydronium ion concentration. What is the difference between the pH range and the hydronium concentration range? I will tell you after that. But firstly, what indicators they given us? They given us the phenolphthalein, they given us the brithamol blue, they given us the phenyl red. So you have to make that type of a pH scale from 0 to 14. Now, the phenolphthalein was colorless. At what range the phenolphthalein was colorless? You have to see. So when you open your acid-base indicators in your last page of your data booklet, you can see the phenolphthalein, they say there's a colorless. So when there's colorless, the phenolphthalein is colorless from, like, they are say colorless to pink. So it's colorless at 8.2, which means the colorless from 0 to 8.2. So in your pH scale, you from 0, this from 0 to something about 8.2 over there. So at that range, you have your phenolphthalein thing, which was colorless. Then you have a brithamol blue. In the brithamol blue, they said this is the blue. So when is blue? This is blue at 7.6, or like after 7.6. So it's from 7.6 to 14. This stays the same, which is blue. So 7.6 right over there somewhat. So 7.6. This is from here to that here, the green part. Then after that, you have your phenyl red, which is red. You can find this is like red. So it's red after 8.0. So it's 8.0. It's center over there, somewhat over there. 8.0 to 14, which means this is from like this thing to this thing. Now you have to find the one thing, that one range where all three ranges are occurring. What is that range? So it starts from like 8.2 to 8. 8.0 to 8.2. The all three ranges are lying that thing. So you will find the average for that. So 8.2 plus 8.0 divided by 2, you will get 8.1. And this is your pH, like this is your average pH. So now you can find your hydronium ion concentration, which you have to find, right? So this is the estimate pH range, which is 8.1. And then you have to find the hydronium concentration. So 10 raised to power minus pH, which is 10 raised to power minus 8.1. You will get 7.94 into 10 raised to power minus 9 moles per liter. And this is your answer for that. So that's how you can work with the pH. We can discuss more questions, and this takes time to how to deal with those type of questions. So I will discuss more questions when we're doing the practice questions. For now, this is all for this, and we discuss the pH, pOH, and how to measuring the pH thing, which is a very important in that chapter. So that's all for this lesson. In next lesson, we start with some strength of an axial basis. That what are the strengths? And this is very important topic, and we discuss some important things in that. So language of EduVibe must not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till listening with EduVibe.